Hi, Assalamualaikum and a very good day. My name is Nur Muhammad Fazli bin Zainun with metric number 264202. We are from group 10 and my group mate is Sri Aruna, anak perempuan Tamil Mani 264861. Poja, anak perempuan S. Nityanantan 264794. Okay, our title of our project is to forecast a cargo of Penang International Airport using multiplicative decomposition method. Okay, for the introduction, this study focus on ensuring that KSP Airport City Holdings Sdn Bhd can manage and fulfill expected demand. Airport City Holdings Sdn Bhd Air Cargo Development is ensuring that the airport can handle future commercial air cargo operations serving the KSP Airport City Holdings Sdn Bhd air cargo market area. Estimating air cargo volume is the first step in preparing for future demand. Time series forecasting was used for conducting the KSP Airport City Holdings Sdn Bhd forecast by using a decomposition method. Decomposition is a popular method among forecasters because it is easy to manage. It provides extra information on the prediction trend and cycle. Okay, next for problem statement. Airline operations are challenging and turning a profit is even more challenging. Despite the difficulties along the way, it is necessary to overcome them. Back then, Malaysia Airport Holdings was in control of Penang International Airport, PIA. So the business climate was different. The air cargo at the current time is in high demand. Due to limit air cargo capacity, Penang International Airport was unable to fulfill the request. As a result, the demand for air cargo is predicted to decline. Although there are many other issues associated with the air cargo operation challenge, the scope of the study will be narrow, focusing on forecasting air cargo volume by means of a decomposition model at Penang International Airport. Okay, for the objective, this study aims to investigate the type of time series model to forecast Malaysia air cargo volume. Second, to identify the best model to forecast Malaysia air cargo volume and to forecast short and long term of Malaysia air cargo volume. Okay, that's all from me.
Now I'm going to explain the methodology part of this research paper. So in this research paper, the data was obtained from Penang International Airport, and the data used in this research are reported in quarterly value from 2008 to 2020. And we use decomposition method in this research to calculate to forecast the short term and long term of air cargo volume. So this is the formula of decomposition method, which will involve the trend, seasonal component, cyclical component, irregular component, and time. So talking about the time duration can be described as week, month, quarter, year, and so on. Based on the data air cargo volume which is obtained from Penang International Airport, the time is measured in quarter, as I mentioned earlier. So, there is two type of a classical decomposition method which is multiplicative decomposition method and additive decomposition method. So this is the formula for both of method. The difference between both method are, in multiplicative decomposition method, we will times the time series component, while in additive we will plus the time series component. So in multiplicative decomposition method, there are two types of model, which is linear multiplicative and quadratic multiplicative, and it goes same goes to the additive decomposition method, which will have linear additive and quadratic additive. So in this research paper, we will compute the MAE, MSE, and MAPE values in this four model in order to find out find out the most significant model to proceed to forecast the short-term and long-term air cargo volume. Thank you.
For the results and finding, in this study we compute four decomposition method models, which is additive linear, multiplicative linear, additive quadratic, and multiplicative quadratic. Excel software was used to analyze the outcome and the most significant model. We manually compute the slope and intercept value to determine trend, y-hat, and error. Furthermore, we compute the MAE, MSE, and MAPE values to determine which model is the most significant to forecast short-term and long-term air cargo volume. The MAE is the most basic measure of forecast accuracy. The absolute error is defined as the absolute value of the difference between forecasted and actual values. The MAE shows us how much inaccuracy we may expect on average from the forecast. Next, for the MSE compute the average of the squared forecast error numbers. Squaring the forecast error numbers causes them to be positive. This also increases the weight of significant mistake. For the MEP is the average or mean of forecast absolute percentage error. As a result, MEP has management appeal and is a common forecasting measure. The lower the MEP, the more accurate the forecast. The MAE, MSE, and MAP value computed for the decomposition method model is used to choose the significant model to forecast short-term and long-term air cargo volume. This is the table. This table is the summary of the MAE, MSE, and MAP value of each model. Based on the table, multiplicative linear has the lowest MAE, MSE, and MAP value. Since MAE ratings are orientated negatively, with lower MAE value suggesting better. There is no such thing as a correct answer in MSE, since the lower value are better and 0 indicates a perfect model. One of the MSE's main use is to choose a prediction model over another. Obviously, the lower MAP value is better. So, the multiplicative linear model is the most significant model for forecasting Penang International Airport short-term and long-term air cargo volume. For the discussion, by calculating the MAE, MSE, and MAP, we can find the most significant and the most appropriate model for predicting the short-term and long-term air cargo volumes. Compared to other models, the multiplicative linear model shows the lowest value for MAE, MSE, and MAPE. Therefore, the multiplicative linear model is the most significant. So, in this study, the multiplicative linear model was used to forecast the result. To forecast the short term, we forecast for the year 2021, and to forecast the long term, we forecast from 2021 to 2030. So this is the short term forecast value plot graph, and this is the long term forecast value plot graph. From the graph, we can see a steady pattern of the estimated values. For the conclusion, the purpose of this study is to evaluate the most appropriate model to forecast for the short term and long term in the air cargo volume of Penang International Airport. As models additive linear, multiplicative linear, additive quadratic, and multiplicative quadratic are analyzed and evaluated in this study to figure out which model is the best solution. As per our comparison, the multiplicative linear model was the least MAE, MSE, and MAP values. Therefore, it is the most suitable model to forecast the air cargo volume. Thank you.